again, it's been a while. We're transitioning today from one dimension to two dimensions, going from just inequalities on a number line to linear inequalities on a coordinate grid.
As you can see, there are no key vocab terms for this particular lesson, but our EQ question states, how does graphing a linear inequality with one variable on a number line compare to graphing a linear inequality on a coordinate grid?
So when we start talking, we gotta take a look at our symbols and how that transitions from one dimension to two dimensions.
So then we have line of a graph will be dashed if it's greater than or less than. And then if we have greater than and equal to or less than or equal to, then the line graph will be solid. Remember, if we're multiplying or dividing by a negative number when solving for y, don't forget to flip the inequality symbol.
Hint, hint, hint. This is the second time we've mentioned this in our lessons. You might want to make sure you make a note of that because that's the one thing that a lot of you will forget. So let's get started. We want to first graph, I gave you a simple one. So our first step is going to be, we're going to graph y equals x plus 5. Then what we need to do is we'll need to determine if the line is solid or dashed, and then we'll get to the next piece that makes it an inequality. So I look here, x plus 5. 5 tells me that I have a y-intercept of 5. Remember, the vertical axis is y, horizontal axis is x. Some of you are still flipping those around. And then our slope is 1, so we go up 1, right 1. And I'm going to go up a couple just to space out my points. And then we want to, with these, you want to have dots all the way to the edges of the graph because I do expect your linear inequalities to be neat and accurate. So I look here, I see that I have a strictly less than, so that means that my line is going to be dashed. So I'm going to dash that out all the way across. Make sure I have my arrowheads. Now comes the shading part. What we're going to do to shade is we're going to test the point 0, 0. Unless, of course, you happen to get a problem that 0, 0 is where the line goes through. Because then it either will work or won't work guaranteed. If this, when you use 0, 0, if it produces a true statement, you're going to shade where 0, 0 is. If it's false, you shade on the other side. So we put in 0 less than 0 plus 5. Well, 0 plus 5 is 5, so 0 less than 5. That is true. That means I'm going to shade using my highlighter. I prefer highlighter just because it's easier. And I'm going to shade on the side that 0, 0 is located. Now, it doesn't have to be super neat in terms of staying inside the grid because remember, our answer ends up going to be everywhere beyond that as well on this side of the line. Now, I am an OCD person. I can't have any white spots in here because that bothers me. But as long as I can tell where it's shaded, I'm going to provide highlighters because I would really like to see you use highlighters or markers and not just a pencil because sometimes pencil is really hard to tell unless you shade really dark. But then you get the issue with the lead all over your hands. All right, let's take a look at the next one. Here, our big difference is that we have standard form. So what we need to do is we need to solve for y. So the first thing I'm going to do is I'm going to subtract 2x from both sides. So then that means I've got negative y is less than or equal to negative 2x plus 6. Well, I can't have negative y, so I need to divide everything by negative 1. And so then I have y, but then that means because I divided by a negative, I need to flip the sign. And so then I end up with 2x minus 6. So I go down 6, and then I have a slope of 2, so up to right 1, up to right 1, and I'm going to make my points all the way across the graph. Simply because then I can make sure that my line is accurate. And then I see that it's a solid line because it's greater than or equal to. And then I need to go shade. So I say, all right, 0, 0. So I've got 2 times 0. I'm using the original equation. 2 times 0 minus 0. So 2 times 0 is 0. 0 minus 0 is 0. 0 is, in fact, less than or equal to 6. So when I go to shade, I'm going to shade on the left side of the line, the left and above, because left and above is where it is, where 0, 0 is. And this is what I'm referring to. If you want to shade like this, please be my guest. Personally, that bothers me, but that's up to you. Let's try another one. Here, I want you to be able to find intercepts. So we look here, and intercepts, remember to find the x-intercept, I'm going to put in 0 for y. So 3x plus 4 times 0. And for right now, I'm going to put an equal sign in. Oops, not 0. Put an equal sign in simply because we don't need to worry about the greater than or less than piece. 4 times 0 is 0. We get 3x equals 12. Divide by 3, and I get x equals 4, which means my x-intercept is 4, 0. For my y-intercept, remember we put 0 in for x. So 3 times 0 plus 4y equal to 12. 3 times 0 is 0, so we get 4y equal to 12. Divide by 4, and I get y equals 3, or 0, 3 for my intercept. So now I put those in, 4, 0 for my x-intercept, 0, 3 for my y-intercept. I see that it's less than or equal to, so it's a solid line. My line as straight as possible, and then I'm going to test the point 0, 0. So 3 times 0 plus 4 times 0 should be less than or equal to 12. Well, those end up zeroing out. 0 is in fact less than or equal to 12, so I'm going to shade on the side of 0, 0. So now, go a little bit different. Now we just have one variable in it. X greater than 3. Well, x greater than 3, I see an x, I automatically think vertical because x has to follow 3. Well, greater than tells me that it's a dashed line, so I'm going to make a vertical dashed line. And then I think of this in terms of if I were shading 2-dimension, greater than points to the right, not to mention that greater than gets bigger to the right. That means I'm going to shade to the right. Whereas when we look at this one, y less than or equal to -5, I see y and I immediately go, okay, vertical axis, 1, 2, 3, 4, 5, -5, point. And that's going to be a horizontal line. Less than or equal to means it's going to be solid. So I make my solid line all the way across. And it says less than or equal to. So then I start thinking of this kind of like a thermometer. Less than or equal to is going to be below. So I'm going to shade down below. Pretty easy, right? So we're not really doing a whole lot different. We're taking what we've been doing already and just kind of mashing some things together. So now we want you to try. We got the first one, y greater than 2, or greater than -1/3 x plus 2. Y greater than or equal to 3x minus 2. Y less than or equal to -1. And x greater than -5. I'm not going to have these set to enter into Edpuzzle because obviously you can't enter a picture. So bring those graphs with you to class and we'll talk about them tomorrow.